Alright, today we're going to take a closer look at sound in a Game Plan cocktail pinball machine. Specifically, the SSU-1. SSU was Game Plan's abbreviation for Sound Simulation Unit, and it was the first solid-state soundboard from this manufacturer, and it was utilized in only 3 cocktail pinball machines:
Star Trip, Family Fun, and Vegas.
Today we're looking at an SSU-1 in a Vegas cocktail pinball machine, and it is this blue board right here. You can see this is the soundboard, and above it is the speaker right here. This is a very simple soundboard, and it was the replacement for a chime box that were in the very first Game Plan pinball machines. And it was designed as a plug replacement for the chime box and plugs into the harness right over here. And this is the harness plug for the sound selects on the soundboard. And if you take a close look at this plug, you'll actually see that there are 5 pins in it. See if I can get a little closer here so you can see this. See, there are 5 pins in this harness connector, and on the other side, connected to the soundboard, you can see there are actually only 4 pins used. And the reason is that 4 of these pins in this connector here go to the solenoid board, and this pin in the upper right-hand corner, in the upper left-hand corner, actually provides power for the solenoids. But that's not used by this soundboard. But it allowed Game Plan to use the same wiring harness, and basically, instead of just installing the chime box, they installed the board and the speaker. So we want to do a little bit of diagnostics on this board and show you a couple of features on it. One, there are 2 user setting controls on this board. This is the volume control pot, and this adjusts the volume for the speaker. And then the other thing on this board is this blue jumper, and this sets the type of sounds that are used on the board. In the position that it's in currently, it's set for calliope sounds, and we're going to hear what that sounds like in a moment. But if you switch it over to jump these other 2 pins like that, it's actually set for what's called sci-fi sounds. So let's set it for calliope and turn this on and see what it sounds like. Let's turn this on, and after it powers up, I need to remember to hook the sound inputs back up, otherwise you won't get any sound. First diagnostic step. Alright, let me turn this on. And as you can see, those are the calliope sounds. Now, if I shut it off move the jumper to the other two pins over here like that and turn it on, you get the sci-fi sounds, and you can hear the difference between the two. Now I've rotated the knob all the way up, turning it counterclockwise as I face the white disc on the side of the knob. If I turn it off and on again, you see I get no sounds at startup. So, pushing this knob down like this, adjust the volume all the way up, and pulling the knob up, adjust the volume all the way down. And as you see, there's my test of the amp and the speaker. So, you know, if you do that, the amp and the speaker are good. And the blue jumper is set right now for sci-fi sounds. But now, what do you do if you're getting no sounds from the machine? Well, there could be any number of problems that cause you not to get sound. And it starts with the MPU board in the machine. And the sounds that get played are selected by the MPU board and then are triggered by the solenoid board down here. So the MPU board here selects the sounds to be played and then triggers the solenoid driver transistors on this board, which are then connected through that connector there and then over to the SSU. So now it's possible that you don't get any sounds. Well, no sounds could mean a problem with the MPU board, and specifically with a capacitor here or one of the solenoid select, the LS379 at U20, or even the PIA. Those need to be checked. But if you get 6 flashes and your MPU board boots, chances are those aren't the problem. It could be your solenoid driver board, could be this decoder, 74154 decoder, or one of these 3 3081s here, or the 4 sound solenoid transistors, which are Q3, Q10, Q12, and Q13 on the board. Or it could be the cable that goes from the solenoid board to the sound select board, and that's easy enough to check. For this, you need a multimeter, and you set it for continuity mode, the one with the speaker, and make sure the machine is off when you do this, by the way. Otherwise, you're going to be touching things that you're going to regret touching. And all you have to do is disconnect the cable from the SSU-1 and there, and leave this to the side. So you want to check for continuity the cable here in the cabinet, and first we start with pin 2 here. You can see, so I stick my multimeter probe here in pin 2, and then down on the SDU cable J2, you also want to touch pin 2 on this as well. You see, if I touch pin 2, I get a beep on my multimeter. Then if I go to pin 3, on this connector, which is this one down here, this is 1, 2, and then this is 3. Pin 3 goes down to the solenoid connector on J2 of pin 6. 1, 2, 3, 4, 5, 6. And you see I get continuity there as well. And then if I look at connector again and go to pin 4, there, that maps to pin 7 on J2. 1, 2, 3, 4, 5, 6, 7. See, I have continuity there. And then finally, I go to pin 5 on this connector, which is this one down here. And that goes to pin 5 on J2. One, 2, 3, 4, 5. So, in testing continuity for this, I know that my cable connections from the solenoid board to the connector for the SSU are working. So you can plug this back in, and we've now tested the speaker and the wiring for the speaker and the amp. On the SSU, and we also know that we're getting power because we got when we touched the volume pot, we actually got the hum in the speaker. I should have also mentioned that in addition to the input connector for the soundboard, which is on this pigtail, by the way, you see it kind of hangs off, and this is normally connected to the cabinet through a tie and a staple. You have your up here you have your speaker connection, and then down here on the bottom, this is your power connection for the soundboard. And this power connection actually comes, as you see down here, from the power supply. And this was the one additional wire that they made. You see it comes, it's kind of hard to see here. See if we can get it. See this down here. It's the cable. It's this cable here, as you can see. Now, let's see if I can get this here. This cable, and you follow it down. And you see it comes this way. It's this cable, and this cable goes underneath this top connector here on the power supply. And it goes to this 100.1 Molex connector right underneath it. that I'm pointing at. And that was the one additional cable that they made in order to feed power to the sound simulator board. Now, to look at a few of the other components on this board and do a few more tests, it's just easier to do it out of the machine, and that's what we're going to do. So here's the SSU out of the machine, and the next thing to do is to further test the pigtail. You could do this in the machine if you wanted. I'm just doing it this way because it's easier rather than being crouched in a cocktail pinball. If you'd run the same tests that I previously showed you from the solenoid board connector all the way to the board here, as these wires through the pigtails, you can see they are connected and go right into the board directly. Well, all I'll do here is I have a jumper lead for one end of my multimeter, and I've hooked this up to the red wire. This is pin 2, and then if I touch either of these resistors here, that are above the red wire, these are all connected together. As you see, I have continuity there. So that's where pin 2 ultimately goes to from the connector, from the pigtail connector. Pin 3 goes to the next one here, and these two resistors right here. And you see, that means that connection's good. Pin 4 then goes to these next two over here, and you see those are good. And then pin 5 goes to these last two resistors here. So you see those are all good. So we know that the connection from the solenoid board to the SSU is good. And we knew our speaker connection was good. We tested that when we rotated the volume pot here and touched it with our finger. We knew we had power as well. So that was all good. There are just a couple other things to consider for this board. If the power isn't good, you could have a problem with one of the caps. There are 4 electrolytic caps on this board. There are these 2 150 microfarad, 25 volt caps. This one here, the one furthest away from the connectors, is actually for the input, and this is for the output. And you have this cap here and this cap here, which is, can't really see it, this is a 22 microfarad 16 volt electrolytic cap. And then that goes to this 9.1 volt Zener diode that's right above it. Hard to see. Let's see if I can get a shot of it here. You can sort of see it there, in there. That's right above the cap, and that rectifies the voltage for this board. And then on the output side, you have this. This is a 10 microfarad 16 volt cap, and then this 150 microfarad cap on the output side. These could be a problem. They're over 30 years old. If you have a voltage problem, you definitely want to check these 2 caps. Certainly if you're going to change this, you might as well just change this, and you could change these 2 as well. This is a pretty simple board to work on. It's a single-sided board. See, there's no traces on this side. All the traces for this board are on this side. So you could have a problem with these caps here. You could have a problem with the the diode that's above this cap right here. Another interesting thing is that this board uses the same green decoupling caps that are used on the CPU board, and these could be problematic as well. And even though this board is working, you see this cap here, it's kind of bulging, and it could probably afford to be replaced, as opposed to the cap that's next to it, which, as you can see, isn't as bulging. But certainly changing these out for ceramic axials would be good. The big thing about this board, and about early game plan sound in general, was the use of this complex sound generating chip. This is a TI-76477, this one right here. And this part is no longer made. This board uses one of them. It generates 4 different sounds, thus the 4 different inputs. And these are controlled directly by the solenoid board. If you happen to have a sharpshooter or an old Coney Island, you'll actually have 3 of these chips on the board and a 74154 decoder that is used in combination with the solenoid inputs to select the different sounds on the board. They said this chip's no longer made. Sourcing it can be difficult. Right now Arcade Chips has this, but they get $10 a pop for them. So if you have no sounds on your board, and if you do the touch test on your volume pot, and your cabling is good all the way from your solenoid board, you really have to suspect this thing as being bad. And hopefully, if it is, you can still get a replacement. A couple of things to note about this board, about the parts used on this board, is that some of these resistors don't actually match up with the parts listing that you can find for this manual online. For example, the parts listing says that this resistor here, this one right here, and this one, and this one, and this one, which is item 24 on the parts listing page. Here calls for a 39K ohm resistor. Well, in actual fact, if we test this resistor with the multimeter, if you take a look at this, you'll see that says 3.27K. These are actually 3.3K ohm resistors, and that's confirmed by the orange-red resistor code on the body of the resistor. So on the parts listing for number 24, instead of it being 39K ohm, it should be a 3.3K ohm. And then the resistors that are right above those, this one, this one, this one, and this one, the parts listing for number 18 says that these should be 22K ohm resistors. But once again, if we look at the multimeter and we see what the multimeter tells us here, that's actually 2.16K ohms. And these are actually 2.2K ohm resistors. And again, these are confirmed by the red, gold color bands on the resistors. And then the other interesting thing to note are these 4 blue tantalum caps that are on here. These are all part of the input select circuit. These are all tied into the input connector. And the parts manual for that says it's a 1 microfarad, a 35 volt dipped tantalum cap. Well, I can't show on my video because my camera's not that good, but if you take a look on the side, it actually says plus 10 16 volts. Well, these are actually not 35 volt caps. They're 16 volt tantalums, and at the plus 10, that would tell me that they are 10 microfarads. And sure enough, if I get my ESR meter out here, and I hook this up, and if I press the button to test, look at that, 10.93 microfarads, 0.96 ohms ESR. So once again, the parts manual is wrong, and item 17 in the manual should say 10 microfarad, 16 volt tantalum. This is important to note because if you have any problems on the input side, you have any one sound missing, you may have to replace one of the transistors, either the 3904 or the 4403 transistor, and the appropriate resistors, and maybe even the tantalum cap, if you have any one sound missing. If you have all sounds missing, you know the speaker's good, your power is good, and your solenoid board is good, you have to suspect the sound generator. If you have any one sound missing, you have to suspect one of these that are over here. Beyond that, the rest of the parts on this board are pretty easy to come by. The volume pot, these caps, the tantalum caps, the resistors, the diodes, everything else. So it shouldn't really be that difficult to get this board working if you have a problem. And that's about it for the SSU-1 from Game Plan. There'll be more to come as we do more of these. Hopefully you'll find this helpful. Thanks and take care.